Okay, so till now we have only spoken about the approach of the utility function without actually going into the mathematical aspect. Today we go into the mathematical aspect. For any utility function, as you can see, utility function looks like this. U is equal to a function of x and y. So if I were to graph a utility function, I'll need the help of a 3D diagram. Why a 3D diagram? Values of x and y will determine how much utility I get. Am I understandable? So the utility function in itself, if I want to talk about mathematically and in a diagram, I will have to show it in a 3D figure. Now, drawing a 3D figure may be easy for you, but for me, it is very, very difficult. Okay. Drawing a 3D figure with different values of x and y, putting in the utility will be quite a challenge for 99% of us. Okay. Therefore, economists took out an extremely smart workaround out of this. Okay. Since they did not want to work with a 3D figure, drawing a 3D figure on a plain paper is not very simple. Okay. We need a 3D graphing. Okay. Hence, the economists took out a very important hack. What hack did they take out? They took out a hack which basically gave birth to a concept called indifference curves. So the economists did not want to work with a 3D diagram, so they came up with a very, very interesting concept called indifference curves. Indifference curves enabled an economist to identify the utility of a consumer in a 2D diagram. Now, how did they do that? Indifference curves is basically the locus of all XY combinations. The locus of all XY combinations that leaves the utility of the consumer unchanged. Okay. So in order to come out of the 3D dilemma, the economists came up with indifference curves. Indifference curves, the locus of all XY combinations that leaves the utility of a consumer unchanged. Okay. Now, what does this mean? What does this mean exactly? Let me draw it here. What this means exactly is something like this. In the XY space, find out all the combinations of X and Y that leave the utility unchanged. So say I want to keep the utility fixed at a utility level of U bar. Okay, it can be any number. You can think about it as a utility of say 10. I want to keep my utility value fixed at 10. If I want to keep my utility value fixed at 10, I can definitely have different XY combinations that give me a utility of 10, right? Like for example, if my utility is say X plus Y, okay, then 10, 0, 1, 9, 5, 5. These are all different values of X and Y, which will keep my utility unchanged. Okay, so I draw the locus of XY combinations that leaves my utility unchanged at say U bar. Now I have a 2D diagram, or I have a very simple two-dimensional plane, which I can easily draw on a sheet of paper. So all XY combinations leaving the utility unchanged is indifference curves. Also notice that these indifference curves can also explain to us the properties of preferences of a consumer that the economist wanted to address. So these are indifference curves. Supposing this is U bar, this is say U naught, this is say U1, and this is say U2. Okay, right? Now, with the property of monotonicity, I saw that more is preferred over less. So if I keep my X the same and I increase my Y, the utility should increase. So if I keep my X the same, this is supposing some X and some Y. This is point A, this is supposing point B, this is supposing point C. So at point A and point B, if I compare the two, I can easily see that same amount of X in A, B, and C, but B has more amount of Y and C has less amount of Y. Okay, just by looking at this and thinking about the property of monotonicity, monotonicity was more is preferred to less. If I say that more is preferred, what can I say about the relationship between A, B, and C? What can I say about the relationship between A, B, and C? Can you put it in the chat box? If I tell you that more is preferred over less. More is preferred over less. And I see that for A, B, and C, the X quantity is the same. The only difference between the three bundles is the Y quantity. So can I pinpoint a relationship between A, B, and C? More Y with the same X, therefore B is preferred over A and A is preferred over C. That is quite clear. Because same amount of X, more amount of Y in B than in A, therefore B is preferred over A. More amount of Y in A than in C, therefore A is preferred over C. So with the property of monotonicity, we can easily say that an indifference curve which is higher than the other will give me a utility higher than the below. That is, if I compare, U1 will give me a greater utility than U0, greater utility than U bar, greater utility than U2. Okay, this has to hold. A higher indifference curve will mean a higher utility. Monotonicity rules out thickness because a higher amount of Y, if it is a thick indifference curve, then a higher amount of Y is also giving me the same utility. So monotonicity is violated when I have a thick indifference curve. Are you understanding that? Therefore, a thick indifference curve is not possible if I have monotonicity, because even if I increase my X or my Y by a 0.01, my utility will increase. Understanding? Therefore, thick indifference curves are not possible if I have monotonicity. What I mean by thick is indifference curves are all XY combinations such that the utility is fixed. So if I have this is supposing my indifference points of X and Y. This is called a thick indifference curve. You can actually call it colloquially a thick indifference curve. This basically means an indifference band. Okay, it's a band of values. It's not a curve anymore. So if this is an indifference band, basically means all XY combinations inside it will give me the same utility. And this obviously it violates the property of monotonicity because more is preferred. So even a minute epsilon increase in my X or Y will increase the utility.